a.m. and was recorded for the following 24 hours.
Perfect. Okay. So we know that I'm measuring the temperature and I'm measuring that for 24 hours. So what is the y-intercept of this graph? Who can tell me?
The temperature.
And what's the number? Like, what's the actual value?
Degrees.
What number?
40.
40, yeah. So where do you guys look when you're looking for the y-intercept?
We look
The left though.
on the left side.
On the
Right.
y-axis.
On the y-axis. That's the most important thing. You look for the y-axis and you look at where it touches the y-axis. So that's my y-intercept. And what does that represent in this context? So what does that 40 mean?
Degrees.
40 degrees. And when is it 40 degrees? At what time?
0 hours.
12.
So it's at the 0 hours, but that's an actual time. So reread the problem real quick. See if you can figure it out.
8 a.m.
Yeah, 8 a.m. There you go. Because it starts measuring it at 8 a.m. So that's the y-intercept. And then the second question says, does this graph have an x-intercept?
No.
That's right. Now an x-intercept is very similar to a y-intercept. It's just you're looking for a place where the graph crosses the x-axis. But
Points in the axis, but it just continue.
right, this graph doesn't really go that far down. It stays on 40 and above, right? It doesn't go below 40. So this graph does not have an x-intercept. And since it's a real world situation, there might be a reason for that. So what might be a reason why it's not?
Oh,
The
because
temperature doesn't
it
drop.
cannot go, the temperature never goes down. It just stays there.
Good. The temperature doesn't go below what?
40.
Below 40. Exactly. If it went all the way to the bottom, how much degrees would that be?
0 degrees.
Yeah, 0 degrees, which like that's really cold. So that kind of makes sense. Imagine if it was 80 degrees and then it went all the way down to 0 in the same day. That would be pretty weird.
Impossible, actually.
Yeah, probably. I don't think I've ever heard of that happening anywhere. Okay, number 3. What is the maximum value?
80 degrees.
80 degrees. Good. And at what time does that happen?
At 8 in the morning.
Here, let me just relabel this. So that's y-intercept. Okay, so the 80 degrees happens at what time?
8 in the morning.
8 in the morning. So we see down here that it starts at the 8, but be careful. Does that mean 8 a.m.?
No.
No, it could be 8 p.m.
Remember, when does the graph begin?
At 8.
At 8 a.m.
Right.
Oh, it's 8 plus 8.
Right. It's 8 hours after 8 a.m. So what time would that be if it's 8 hours later?
4 in the afternoon.
4.
4 p.m. Exactly. So what does this represent? Who would like to put that into a sentence? What did we just...
about number 3?
Yeah, so can anyone summarize what we just said?
So you said what is the maximum value, right?
Mm-hmm.
So pretty much since it goes up to 80 before it decreases, is the maximum value 80?
Yeah.
All right.
So it goes up to 80 degrees at 4 p.m. All right, and then finally, name one interval during which the temperature decreases. So can anybody name one interval where it's decreasing?
What's an interval?
At
So
40?
Okay, so yeah, so an interval, let me answer that question first. An interval is an amount of time. So from when to when is it decreasing?
Oh, 5 to 10
5
p.m. to 10 p.m.
Cool. Okay, so hold on, let me just let some people in. Okay, so you say 5 to 10? So we start at 5. Now, on the graph, this is the number 9, right? But we know that it started at 8 a.m., so 8 a.m. plus 9 hours gives us 5 p.m. So this is 5 p.m. And when does it stop decreasing?
Oh, 11 p.m.
Well, it's on the 11,
7 p.m.
but that would be 7 p.m., yeah.
Okay.
So from 5 p.m. to 7 p.m., the temperature drops from 80 down to 50, which makes sense, right? In the afternoon, things get cooler down, the sun sets, so there you go. Now, I'm going to name that interval using the inequalities, just like kind of we did on Tuesday. And I'm going to use not the 5 and the 7, but I'm going to use the 9 and the 11. So from 9 hours, less than x, less than 11. And if you were here on Tuesday, you'll remember this is how we write intervals when we're talking about them in algebra class. So I'm not going to write down, I'm not going to write all those words, right? I'm not going to write from 9 to 11. I'm just going to write this interval, and it means the same thing. And that's only one interval. So can somebody give me another interval? Because there's one more place where it's decreasing.
14 and 16.
And 16.
Okay, yeah. So look very, very carefully. If you follow that
15.
line, yeah,
15 to
it's
16.
15 and 16.
15 to 16. So how can I write that as an inequality?
15 is less than x is less than 16. Okay.
Perfect. Just like that. It's like one of those things that's kind of a little annoying, but it's really not that hard to like just remember how to do it. So if you're ever having trouble with that, just ask and I'll make sure I explain that. Any questions on any of these vocab words or just any part of this problem?
Miss, how did he come up with the equation 15 less than x less than 16?
Okay, so we were looking on this, I'm gonna make it a different color so it's a little clearer. But on my graph, I'm looking at this little segment right here where it goes down, right? So I know it's decreasing during that time. Now I look down at my x-axis and I see that this is 15 and then it stops at the 16. So from 15 to 16, it's dropping. And the reason I write it this way is because that's just simply how we write inequalities. So since I know it's dropping from the 15 to the 16, I have to write 15 less than x less than 16. So I'm literally just writing it like the x is in between, because what I'm talking about is how much time, right? So I'm talking from 15 hours to 16 hours. Everything in between, that whole time, the temperature is dropping.
Miss, how do you know what sign to use?
It's always going to be less than. And then sometimes you might see less than or equal to, but you're not going to need to like distinguish those. The answer choices will be very simple to know which one's correct. Any other questions?
No.
Cool. All right, so next up for today, our topic of the day is understanding functions. So you're going to write down the definition in a little while, but functions are a special type of graph. So we've been looking at graphs, we've been looking at relationships and graphing those relationships and kind of telling a story, right, through a graph. Well, now we're going to talk about a very specific type of graph, which is going to be our functions. So what I would like you guys to do is you're going to write down, there's just a couple of definitions. Hold on. Okay. I'm going to highlight each one. So I'm kind of splitting this up into 3 separate definitions. So technically we have 5 definitions, 6 definitions, but they're all kind of short. So take just 4 minutes to start writing those down, and then we'll meet back together and I'll explain everything. So if none of this makes sense to you right now, do not worry, because you know it will by the end of the class. All right, 4 minutes on the clock. All right, okay. So hopefully you guys wrote most of that down, but we are gonna do a couple more things. So if you're not done, that's okay. Now, before I do anything, let's just notice some things, right? So notice how the ages, what do I call that first of all? The ages, is that my domain or is that my range?
Domain.
Good, that's my domain. And then I have my range. So with a mapping diagram, you're always gonna go domain on the left and range on the right. Now the other thing I wanna notice is how come there's fewer numbers in the domain than there are in the range?
Is it because they repeat them?
Yeah, so what's repeated in the list?
The town.
Okay, so notice how there's a 10, 52, and then there's 10, 53. So basically in the mapping diagram, the 10, instead of writing it twice, you just write it one time, anytime it's repeating. Okay, so then what you're gonna do, anytime you see a mapping diagram, we're gonna make arrows. So you're gonna draw an arrow from the number in the domain to its corresponding number in the range. So my 7, for example, corresponds with the 41, right? So I'm gonna just draw an arrow going from the 7 to the 41. And I'm gonna do that for each number. So then I have 8 goes to 45, 9 goes to 49, 10 goes to 52, but then what happens?
Another 10 goes to 53.
It also goes to 53, exactly. So I'm gonna make a double arrow. It's gonna branch out to both of those numbers. And then the 11 goes to the 55 and the 12 goes to the 59. So that's it, that's my mapping diagram. And so the reason that we do this is because the mapping diagram might help you to notice something that you don't see right away when you're just writing it out in a list or on a table. And what we see here is that the 10 branches out. And that's going to be pretty important in the next section of what we're going to talk about. So again, just to reiterate, the domain is all the X values. So if I wanted to state the domain would be 7, 8, 9, 10, 11, and 12. And then the range would be all the Y values. So the range would be, who would like to list out the range?
41, 45, 49, 52, 53, 55, and 59.
Exactly. It's basically the same thing. That's why I didn't have you guys write this part down, because it's like the same exact thing. Okie dokes, any questions so far? With the mapping diagram, anything like that? Cool. All right, so now we're going to talk about what is a function. So remember, that's our topic of the day. The topic of the day is functions. So can I have a volunteer read for us the definition of a function?
A function is a type of relation in which there are only one output value for each input value. For
Right.
every input value, there is a unique output value.
Perfect. Okay. So this is a very, very important definition, and it might not make a lot of sense right now. However, this is going to come back over and over again. So it's very important that we write it down and we memorize this one. You might not understand what it means yet, but you will by the end of class. So just make sure.
Shut the fuck up.
Oh,
That's what my grandpa left me.
okay, all right. I'm gonna remove this person.
I knew that person once.
I know, he kept trying to come in too, so I was
For
like,
real?
not sure. But I wrote down his name, so we're good. All right, so anyways, go ahead and write that down. It's gonna take just a couple, I'll put just 1 minute on the clock because it's pretty short.
Miss, I don't understand how they get it because like you only posted on here.
It's either someone who's in my class or like the sibling of someone who's in my class. I don't know, but the person's name was Martinez. So there's a lot of that's the problem. There's a lot of Martinez's. I think I have like 3 Martinez's.
Miss, it
in this
wasn't me.
class.
It's me.
You
I'm
sure,
Miriam
Miriam? You
Martinez.
sure?
Very much Miriam Martinez.
No, I know anyone who's here, I obviously know it's not you.
Man, she's innocent.
It was Cassie Martinez.
My 2 Martinez are innocent. Cassie and
Yeah,
Miriam.
Cassie and Miriam, they're innocent, miss. I know them.
Cassie is
We and
the
Melanie know
person.
them.
Cassie is
Yeah,
the
miss,
person.
we know them. They're innocent.
Okay.
No, miss, it's Cassie Martinez. They lied to you.
Wow, you doing that to
For
your best
real, you
friend?
confronting
Wow.
your old friend and stuff.
So if it's not Cassie Martinez and it's not Miriam Martinez, is it possibly
It's
Andy
Andy.
Martinez?
It's Andy.
Andy Martinez. There you
damn.
go. It's Andy Martinez. Sorry,
Oh
miss.
no, miss, yes, because
gave you
it
false
popped up on my
information.
screen that he unmuted himself.
Uh-oh, Andy, what you gonna do? You're on trial.
Ain't nobody finna save you from this one.
Miss, me and Melanie are the lawyers for Miriam and Cassie, miss.
Yeah, miss.
Oh, you're gonna defend them?
Yes, ma'am.
Who's my lawyer?
I'm your lawyer.
Oh, okay, I
Cassie,
got
miss,
Cassie. I got Cassie.
period.
Fine. I got Cassie.
My lawyer, you see, she got my back. That's why you're not getting paid.
All right,
Marion,
y'all.
don't come for me.
All right.
Cassie, you want me to be your lawyer? I can be both.
Wait
Yeah,
for that.
she can get both of you. All right, let's get back. Okay, so a function is a type of relation in which there is only one output value for each input value. Okay, that's the most important thing. However, there's another way to say that, which is that for every input value, there is one unique output value. Now, that's a lot of gibberish if you don't know what I mean, so I'm going to explain it, okay? So a function can be shown in 3 different ways, just like a relation. You could write it, you can make a table, you can graph it, and you can make a mapping diagram. And the most important thing to notice when you do these things is to see how many times an x value comes up. So you know how in the previous problem, I'm going to go back really quick to the previous problem. What was going on in the x values in the domain? Does anyone remember?
The 10 repeated
They
itself?
repeated.
Exactly, the 10 repeated itself. When that happens, on a mapping diagram, you can see it because you can see the arrows branching out. When that happens, that means that the relationship is not a function.
I just did
Because-
the Khan Academy assignment, what you just said, I literally just got 100.
Awesome, good. So that's the thing, is that in order to be a function, each value from the domain can only have one arrow. You can't have double arrows because it can only go to one unique output. So each input can only go to one output. That's the most important thing. So on a mapping diagram, if it's branching out, that's not a function. So let's look at this mapping diagram. Notice what is similar about this mapping diagram, but a little bit different.
This time there's two of the x's
285s.
pointing to the y's. I forgot how to
Yeah,
pronounce
so it's kind of the
it.
other way, right? Like here, instead of branching out, the inputs kind of come together. They converge. They come together on the 85. That's a different thing. If that happens, that is still okay. That still makes it a function. So the only issues that you can ever have is if the x values are the ones that are repeating. Are there any x values repeating over here?
No.
No, right? So we know this one's good because there's no x values repeating. So this is, all three are actually, all of these three, the table, the graph, and the mapping diagram are all showing us the same function. So if you notice, it goes 20, 30, 35, 60. That's the same thing here, 20, 30, 35, 60. So there's 3 ways of showing the same thing. And in each of those the table, the graph, and the diagram, there's different ways to tell if it's a function or not. So on a table, you always just want to look at your domain, at your x values, and just check that there's no repeating numbers, right? That's all. On a graph, you want to see if there's any dots that are stacked up on top of each other. So let me show you what that looked like before. In this scenario, in this example, notice how these two dots are stacked up. Those two numbers correspond to these two values in the table. So the tens, those two tens are repeating, and then on the graph, it looks like that. They're stacked up on top of each other. So that's bad. That's how we know this is not a function. However, over here, are there any values stacking up?
No.
Right. So since they're not stacked up, we're good. This is the function. So this one is a function. We're going to look now at a few examples where you guys have to figure out, is it a function or is it not a function? So let's see how much we understand. So take a look at these two tables. I want to know which one of these is a function and which of these is not a function. So start just looking at it. And if you feel like you know the answer, you can go ahead and say it.
Is table A the function?
Good. Table A is our function. If you look at the x values, do we see any repeating numbers?
No.
No.
No. So we're good. This one is a function. On table B, however, what's the issue?
There's two 15s.
There's two 15s right here. As soon as you see that, that should immediately say to you, nope, not a function. Okay. Even though on the right side, actually on this one, it's not even, never mind. Now, one last thing which you might see, especially on Khan Academy, because they love to do this little trick. I'm going to change something real quick. Let's say on table A, I added one more, and I added 2 and 5. How about now? Is this still a function?
Yes.
No.
No.
Yeah. No. Actually,
So wouldn't
yes.
they be the same
No,
thing?
because you're
It
Yes, it
repeats
is.
itself?
It's repeating both of them. They're
So
both,
it
the X
just-
and the Y is repeating.
Yeah.
It's the same
Yeah.
place.
Exactly. So even though it repeated, there's two 2s now. If you look, and you look carefully, here it went to a 5, and here it also went to a 5. So technically this isn't repeating, it's just rewriting the same point. So they love to throw that one in on Khan Academy. So anytime that you see repeating numbers, just check to make sure that they are going to different values.
So it's still considered a function?
So table A would still be considered a function. Table B, though, since those 15 goes to 10 and 10.5, 10 and 10.5 are not the same. So that one is not a function. Okay, does that make a little more sense? I just wanted to throw that in there because I know it'll come up. They love to do this. All right, so now the next question is for you guys. This is for you to answer. I'm going to put a poll. So start reading it to yourself. Start seeing if you've got an answer for yourself, and then I'll have the poll ready to go. All right. So when you've got an answer, go ahead and put it in the poll, and then we'll see who wins. See if you got it right. And by the way, this is what this type of problem looks like on a test. So, you know, on tests, they try to trick you a little bit. Interesting. I'm seeing two answers that are both coming up equally. 11 people have voted out of 17, so I'm waiting on 6 more students. Try and get an answer in the next 15 seconds. All right. Even if you got a guess, go ahead and guess in 5, in 4, in 3, in 2, and 1. Here we
Miss, do
go.
those thingies like do they equal like participation or something like that?
Yes. I'm always looking at who's participating. So you guys can't see who put what, but I can. That's how it works. Okay, so
Oh
here we go.
wow.
Let me share the results. So here's the results. B won by a tiny little bit. So I can see how, everybody all over the place. There wasn't any clear winner, but that means let's check it out. So let's check it out. What do you guys, those who voted for B, would anyone like to say why they voted for B?
Because it's the right answer.
Be more specific. You don't know that yet.
Even though I chose D,
Because
I just know it's the right answer.
Y'all wrong. Let me stop. Let me
Miss,
stop. I'm
I'm
gonna sound
not
like a
even
clown
gonna say
if I'm
what I
wrong.
chose because I know I'm wrong in the first place.
You don't know. If you
even
chose
though I
B
chose
though.
D, I think it's B because because a function because there's only one output for each input because for example
Amber, how many cusses are you gonna say?
the output only has 3s.
Mm-hmm.
And then table B has 9, 12, 15, and 18.
Okay, so remember, we're always looking at the X values first. And we're looking for what?
Oh, Miss, it's D because every
Period.
input. Wait,
Yes,
Yeah.
sir.
I lost it.
Yeah, finish it. You had it. Every input
has like its output or something like that.
Every input has its own output. Exactly.
Yes,
You
sir.
said it perfectly. Now, what's wrong with table A? Why is table A not a function?
There's
because
two
it has
twos.
two
Because
twos
it has
on the input.
Different output.
Right. The 2 goes to the 2, but the 2 also goes to the 4. So those inputs have 2 outputs. The 2 has 2 outputs. So we know that A is not a function. So I can cross out A and C. But then between B and D, they really try and trick you because they want to make sure you know the exact definition. And that's where it gets a little hard. So I'm going to go back real quick, reread for yourself the definition. Reread it really quick. A function is a type of relation in which there is one output value for each input value.
So it's D, right, Miss?
One output value for each input value.
Miss, I got it right. It's D.
Damn, I sound like
is-
a
Oh, never mind.
clown.
It was B, not D. So notice how they try.
Kind of right.
All they did was they switched those 2 words and they're trying to see if you know which one it is. So that's why I told you, even though it's just a bunch of words, you have to memorize that definition and memorize it in the correct order because they will try to throw something like this at you.
But I was on the right track, Miss.
You were on the right track. If you chose D, you were pretty much 50% right because you knew it was table B, but then you got the reason wrong. Any questions on this one? Does it matter that there's a bunch of 3s here? Does that matter to us?
No.
No.
Oh,
Nope, we do not care. That's fine. All right. Now, let's look at some mapping diagrams. So remember what I said. What's the bad thing? What do we not want?
Repeated output.
We don't want any repeated inputs. And on a mapping diagram, what does that look like?
on top of each other.
Another one.
Mm-hmm. So on top of each other is for the graph, but on this diagram, what type of arrows are bad?
There. Never mind.
Like the 5 that's going to the 2 and the 4.
Mm-hmm. So I kind of call that like a double arrow or like it's branching out, right? So since that 5 is going to 2 different places, you can't be in 2 places at once. That's kind of the idea. Like you can't be in 2 places at once. So the 5 can't go to both of those places. Same thing with the 11. The 11 goes to 2 places at once. And so because of that, so anytime you see a double arrow like this one, that's how you know it is not a function. Now on the other hand though,
The other one is a function because they have a different output, I think.
right, each number goes to its own location. It doesn't go to 2 places. Even though here, they're kind of coming together, that's okay, that's allowed. As long as each,
It's not the same input going to an output.
right, they're coming from 2 different places and they're both kind of meeting at the same place. That's different from the diagram B where one input is branching out into 2 different outputs. So if you're having trouble remembering how to do that, just try and think like you can't be in 2 places at once. So the 5, he can't be in 2 places at once. That 11, you can't be in 2 places at once. That's bad. That's not a function. And so just like before, I'm going to have you guys try one on your own. So do I have any questions before you try the one on your own? Okay. So again, this one was from a test. So they always try and trick you in some way. Read it carefully and try your best. Go ahead. Okay, I'm almost at 13 people. Let's see if 15 more seconds. 5, 4, pick a number, 2, and 1. All right, y'all, moment of truth. Let's see what happened. 3, 2, 1. Oops, there we go. Oh my gosh, there we go. All right, so the answer choice A was the most popular one. Would anyone who chose A like to explain why they chose A?
Because each one chooses his own one.
Each arrow goes in one direction. Are there any double arrows?
No.
No.
Okay, so notice how one of them is crossing the other ones. So this one's kind of crossing through. Did I ever say that was a bad thing?
No.
No.
I never said anything about that. So that's fine. It's not breaking any rules, basically. So yes, this one is in fact a function. What's wrong
Miss,
with?
I put A because it's not coming from like they're meeting and then they're separating. They're like separated and then they meet somewhere else.
Right, they're all separated and they all end up in their own unique place. What's wrong with C and D? What do those have?
They
Meeting and then
both
They have
separate, like,
branches.
separating.
A lot of branching, yeah. C has 2 branches and D has 2 branches as well. And then B was kind of a weird one, but what's wrong with B?
Oh, it has no input.
So one of the inputs does not have
So it's A?
an output. Yes,
So
so
the
the answer was A, yes. Because you're always looking for the one that has no branching. There was no branching for A, so we know that one's correct. Is anyone still a little confused and would like me to explain a little better?
Miss, I finally understood a lesson.
Good job. This chapter is fun because there's not as many numbers. It's more like visual.
I guess I like this better.
Me too.
So smart.
Okay. Now, what if you get a problem and all it's giving you is the list of points, right? So it might just be like, here's a relation. Let me know if this is a function. What can you look for if it's just a list?
That you don't have the same two inputs, I think.
Yeah. So you're going to look at your inputs, all of the x values. Now, if you're like me, I'm a very visual person. I like everything to be very organized. I like to see things in a very organized manner. So for me, this list gives me anxiety. Like, I don't like looking at all of these numbers all up together, and they're always blurry for some reason. Why are they always blurry? I don't know.
Yeah.
So what I
Gives
like
me
to do,
anxiety just looking at different stuff.
yeah, it makes me like dizzy. I don't even like this. So what I like to do is I like to turn my list into a table, just a very basic table, just so that I can visualize it a little bit better. So if that helps you, do it, because anything that's going to help you is good. So I'm literally just writing each point down on this table. Because that helps me to visualize it a little bit better, but I'm still doing the same thing. I'm just looking to see if there's any x values that are repeated. And in this case, do I have any x values repeating?
No.
Good. So is this a function?
Yes.
Yes, this is a function. So you're going to do the same thing in the next problem. You all ready?
So miss, so basically you look at the x, and if it's a number repeating, then it's not a
Right.
function.
Right. And then remember what I said before, though, that sometimes they like to trick you a little bit. So be very careful, because what if they did this? What if they had one more and it was this? Is that still a function?
Oh
No,
yeah.
because the third one has
Yes.
4 and the last one has 4.
They both have a 4, but both
They both
4s.
have a 5 too. So they're not going to the
Well,
same
it's still a
place.
function because both of them have the same thing.
Yeah, so they're the same. So that doesn't matter. That's still a function. They always try to trick you. So don't get tricked. All right, here we go. Let me put the poll. Okay, there you go. So it's another one of those questions where if you get yes or no correct, you have to make sure you also have the reason correct.
Mm-hmm. Oh.
All right, I have 9 answers. If you're stuck between 2 of them, remember the definition. Always go back to that definition. And just like I predicted, we are kind of stuck between 2 answer choices. So I'm still missing 5 votes. Can you 5 people try and get it in the next 10 seconds? 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay. Let's see. This was very interesting. Let me share the results. So we seem to be split mostly between A and D, which is interesting to me because A says no and D says yes. So it seems like we're a little stuck between if it's a yes or a no. So let's look. I could make a table if that helps. Or what else if I don't make a table, either way, what am I always looking for?
You're looking at the input.
You're looking at the inputs and you're looking for any repeating numbers. So are there any repeating numbers in my domain, in my input?
No.
No.
No. So just from that, before I even look at the answer choices, you should already know just from that, is this a function, yes or no?
Yes.
This is a function.
Yes.
Oh, I was looking at the 0 and the 0, so I'm like, wait. And plus, I thought it was from the origin, so I'm like, no.
Did Ms. Lopez say anything about the
No.
origin?
Oh, just
I never said anything about
At
the
all,
origin.
miss.
You know why they put that in there? Because they're trying to do what?
Trick you.
Trick
Okay.
you. And they got you. They
No,
got
they
you, Dejuan.
didn't.
They got you, Dejuan. You got.
They didn't get me, miss. I'm smart like that. Let me stop. No, no.
Okay, so they're really just trying to trick you. So because it all goes back to the definition. Did the definition say anything about the origin?
No.
No. So the origin doesn't matter. What matters is that each input value is paired with one output value, and that makes D the correct answer.
Hey, I got it right.
Does anyone have questions on this one? Because that one was definitely a little bit surprising for me.
Miss, that was easy for me.
That was easy.
Does anyone have
You
any
know, it's
questions?
really
Melanie,
hard
we're
for me
proud
to
of
say that
you.
something's easy, miss.
Yeah,
So.
Melanie,
Yeah,
we're
that's
proud of
true.
you.
I'm proud of you, Melanie, because I know you were having a hard time with the previous chapter. So it feels good, right?
Yeah.
Okay. All right, so here's our last part. I only have 2 more slides. That's it. Remember, you could do
We
it.
all know number 1 is wrong, the A.
So remember, you got a table, you got a mapping diagram, and then you can have a graph. So on a graph, things are a little bit different. Because on a graph, you don't have numbers, right? So like you can't really look for repeating numbers because you don't have them listed. However, what you can do is this really fun thing called the vertical line test. So here's what it means. If you have a graph and you're trying to figure out if it's a function, what you're going to do is you're going to draw a vertical line anywhere. And vertical means up and down, right? So make sure you're drawing a line that's up and down. And you're going to see how many times does the graph cross that line. So how many times does my weird zigzaggy guy cross the line?
3 times.
Twice.
So I've got 1 here, 1 there, and I have 1 more right there. I've got 3.
Oh, sorry.
So remember at this point, go back. I'm going to go back really fast to like the first thing we did. Remember how I said when the 2 points stack up on top of each other, that's bad, not a function?
Yeah.
Same thing applies even if your graph is a connected line like this one. So along that
They're
red
on
line,
top of each other.
yeah, those 3 dots are on top of each other. So because that's happening, this is not a function.
We could have already tell by that line.
Okay, so anytime it's stacking on top of each other like that, it is not a function. Now let's look at B.
But what about B? You can't really put like a line there.
So I could put a line. I'm gonna put a line anyways. How many times does my line cross that wave?
Once.
Just once. So are there any points stacking up on top of each other?
No.
No.
And I can do that in a few places just to check. How many times does it cross there?
1.
Uno.
1. How about here?
1.
1.
1.
1.
1. So is there any place where it would cross multiple times and stack?
No. So that means it's a function.
So this one, since it doesn't stack anywhere, this one is a function. Okay, so you're always trying to see if there's anywhere on that graph that's going to stack. So now look at graph C. Graph C is just a bunch of dots, but we can still do the same thing. We can look for a place where the dots stack up. Does anybody see a place where those dots stack up? Melanie?
I think it was 8, but I can't really see it.
So on the 8, yeah.
Yeah, on the 8. There's 2 dots, so it's not a function.
Right, and I can still draw a vertical line because that still allows me to see exactly where those 2 dots stack, which means this is not a function. And that's how easy it is on a graph. Like, you don't have to think about numbers, you don't have to think about things repeating. Just look and see if there's any place where that graph stacks on top of each other. So, y'all ready for the last question? This is it. We're gonna finish that early today.
Miss, that's so funny.
All right, here we go. So this one, I'm not gonna put up a poll because for each of these, I wanna say if it is a function or if it's not a function. So just have your answer ready. You can put it in the chat, but I wanna know yes or no, is it a function?
Right now?
You can send it in the chat, yeah.
Miss privately, right?
Mm-hmm. So I got a lot of answers all at once, so I'm only sending a response to the people who got it right. So if you haven't heard back, that's because it's wrong. Okay, a couple more seconds if you want to send me your answer and check to see if it's correct. All right. So with number 15, who would like to tell me yes or no?
No.
It isn't a function.
It
No.
isn't a function.
Good, it is not, because anywhere on the circle, if I draw a line, what's going to happen?
They're gonna be on top of each other.
It's overlapping twice.
Right. Right here, those two dots, those are on top of each other, so this is not a function. How
I
about
said it
number
wasn't
16?
a function because of the line in the middle.
Well, the line in the middle is just the y-axis. Those are just
Yeah,
the
but it
y-axis. and the
still
x-axis.
looks like it's not a function. I mean, in my brain, I don't know.
Okay, as long as you got it right, you have your own method. How about number 16?
It is a function.
Yes.
Good, it is. There's nowhere that it would cross on top of each other. Everywhere you try, it's only going to go once. You're only going to see one dot. So this one's all good. All right, and then what about number 17?
Not a function.
It's not a
Okay,
function.
that's why I got it wrong.
Yeah, so look at number 17. Every single pair is on top of each other. Right here, those two are on top. These two, they stack. And then these two, they also stack.
Also, when it has like a dot graph, it can't overlap once.
Yeah, it could only go once. So you can't have any 2 points that are stacking. So this one is not a function.
I see now.
Good.
Well, that was the easiest thing I've ever learned.
Good. All right, so before I go over the next thing, this is a reminder. So I don't know how many of you are here. I see Zakaya. Who else? Naomi's here. Okay. You guys, there's no school tomorrow. There's no classes tomorrow. So all of you on this list, you have to finish iReady. There's no more excuses. Okay? If you're having trouble with a technology device, that's one thing. But if you just haven't had time for it, you're going to have all day tomorrow. So you better get it done. Because guess what? Algebra is the closest to getting 100% completion. All the other grades are really far below. So algebra is the closest, and I want to win some Uber Eats for myself, so y'all better win for me. Okay, so I'm
Miss,
looking at you.
Miss, so you're
I want
using us
Uber
for
Eats
food.
too.
You're using us for Uber Eats.
Of
Yeah,
course I'm
Miss, you're
using
using
you.
us. You can't do that.
What? Who says I can't? Come on.
Me, pretty much. Like last
Just for that, y'all don't do your
Y'all better do
Don't
it.
do it, okay? Don't do it.
So,
Unless we're gonna get a prize, then
I'm just
do
playing,
it.
Miss.
well,
Get her
okay,
so she can get
maybe
some
maybe
Uber
if
Eats.
I get Uber Eats, I'm not going to forget that, okay? I'm going to remember who was responsible for my Uber Eats winning.
All of us.
Okay, so those, yeah, I think only
You can
Naomi,
send us a
Zakaya
fry,
here.
Miss. At least.
Maybe, I'll think about it.
Melanie, you're her.
So that's one thing. And then the other thing is, you guys, like I said, there's no classes tomorrow, so you're not going to have your weekly quiz, no quiz. However, there is Khan Academy. So no quiz, but I'm going to give you a little bit of homework. But the homework is super easy. So if you look, it's already up. It's so easy. It's literally exactly like what we were doing today. So it's going to be like, is this a function? And then you click yes or no. And the whole thing is
wow, you finally say something's easy, Miss.
And I mean it. I mean it. This one's super easy. All of it is yes or no questions. There's no math. There's nothing crazy. So y'all better do it because that's an easy A.
Needs to get 100 because that's what I probably did.
I wanted to give you guys a chance to have an easy one because I know you guys want your grades to go up, right? So
yeah,
use
Miss.
this as an opportunity to bring your grades up, but you have to do it. So don't forget about it.
I'll just do it today, cause
yeah, do it right now. If it takes more than 10 minutes, you're trying too hard.
All right. I guess I'm gonna be trying too hard like multiple times.
I swear we all better get an A, Miss, or we're complaining.
Okay, you better then. Any last questions before I let y'all go a little early?
No, we're done, Miss. We're done.
Okay,
Can I
we are
head out?
done. Y'all can head out.
Miss, have a good day.
Have a good weekend, y'all. I won't see you again
Yes,
till Monday.
You have a good weekend too, Miss.
Thank you.